we move on, let me give you a question. What is a polynomial approximation? Polynomial approximation or linear approximation is when a complicated function is replaced with a line to approximate the function. Here is an example. Function x is equal to sine x over x if x is not equal to 0 and 1 if x is equal to 0. Now, if we have two functions, which are function f and g, that can differentiate, let's say that the value of x is equal to c. Then we do the differentiation steps, the first derivative and the second derivative, and so on. Then we can conclude that fx is equal to gx.
Hello, Dr. I'm Andikan. So the main end of approximation is not only to find a polynomial that goes through a few points on the function, but we also want the error between our approximating polynomial and the function to be as small as possible. Branch phenomenon is a problem of oscillation at the edges of an interval that occurs when using polynomial interpolation with polynomials of high degree over a set of piecewise interpolation points. The figure below is an example of approximating e to the power negative 12 s squared between negative 1 and 1. The figure shows that as we increase the order of the polynomial, our maximum error between e to the power negative 12 s squared and the approximate polynomial is actually increasing near 1 and negative 1. This increase of error close the edges is known as branch phenomenon. Chebyshev nodes are specific real algebraic numbers, namely the roots of the Chebyshev polynomials of the first kind. They are often used as nodes in polynomial interpolation because the resulting interpolation polynomial minimizes the effect of branch phenomenon. From the figure below, the x values were calculated using the formula for Chebyshev nodes. This figure should be compared to the figure exhibiting branch phenomenon. It's obvious the maximum error near the edges is much smaller in this case. When Chebyshev nodes are used, the maximum error is guaranteed to diminish with increasing polynomial order. The Ramesh algorithm is an iterative algorithm that starts with the Chebyshev nodes and moves them around until the maximum approximation error is minimized. The steps are: first, a polynomial approximation of the function at the Chebyshev nodes is obtained through Lagrange interpolation. The second step is the error between the approximation and the function is calculated. The extrema of the error function are recorded. The third step is solve the n plus 2 simultaneous equation, where n is the polynomial order, where xi is the ith extrema and r and e is the polynomial and the error respectively. And the formula is shown below. The fourth step is solution of step 3 should give new polynomial coefficients. We calculate the error using these coefficients and find the extrema of the new error function. Go back to step 3 until E converges. The approximation error using three different methods of calculating the approximate polynomial is shown in this figure. The magnitude of error is statistically reduced by using Chebyshev nodes and reduced even further with the application of the Ramesh algorithm. To reduce the error further, higher order polynomials can be used. There's however a trade-off. We use approximation because they are quick to compute and higher order polynomials take longer to evaluate.
Now, these are the advantages and disadvantages of using polynomial approximation. The first advantage is it is easy to interpret the coefficients. Polynomials are suitable for all types of curvature. And the last one, can use any size of the dataset. Now, for the disadvantages, the first one is it is too sensitive for the extreme values. Extreme values is when the data is too big or too small than the other data. For example, if we have the value is 100, 200, 300, and the last value is 1000, then the 1000 is the extreme value. For the second disadvantages, if the data has more than one extreme value, of course it may affect the outcomes. And the last one, errors may occur in the coefficient value if the degree is greater than 4.
Okay, so now let's head to our animation video which is related to our project titled Roller Coaster. Mr. Chong is a structural engineer. He is given a project to design a roller coaster track. There are few requirements for the project. The first one will be there is 3 maximum and or minimum. The second one is the ride length must at least 3 minutes, and the last one is the roller coaster must start at 250 feet and dives into the ground at least once. Then Mr. Chong starts his project by sketching the graph of the roller coaster track, and this is the sketch of him. Next, Mr. Chong finds the intercept of the roller coaster graph and also the factor form of his graph. The factor form found is x minus 1 times x minus 2 times x minus 3 times x minus 3 and times x squared plus 1. After that, Mr. Chong and his team were thinking using polynomial to approximating their graph function. Then, Mr. Chong expands the factor form into the polynomial function. The final answer found was shown in highlighted red color. Thus, the y-intercept which is located at 0, 250 is used to find the value of A, and the value of A is 13.9. After that, Mr. Chong finds the standard form of the roller coaster by multiplying the value A into the polynomial function. The final equation is shown in red highlighted color. Then, Mr. Chong used the synthetic deviation check to ensure 1, 2, and 3 are the roots of the equation. Now comes to the ending behavior. Mr. Chong concluded that as x going to infinity, y goes to infinity too. When x goes to negative infinity, y goes to infinity. The hypothesis concluded by Mr. Chong is accepted as the graph gives a parabola shape which included 1 maximum and 2 minimum. Besides that, it also suits the roller coaster that starts off going down to get speed and ends up going up to reduce speed. After that, Mr. Chong finds the domain and range. The domain of the graph is x is in between 4 and 0, while the range is y is in between 250 and negative 100. Based on the x-axis, which is time, the domain is realistic as the roller coaster ride is in between 0 and 4 minutes long, while based on the y-axis, which is height, the range is realistic as the roller coaster ride starts at 250 feet, then dips below to the ground to negative 100 feet. Then, Mr. Chong writes down the increasing and decreasing intervals. The increasing intervals is shown by the red highlight, while the decreasing intervals is shown by the green highlight. It finally comes to the end. Mr. Chong has finished the final graph by labeling everything on it. The labeling included the x-intercept, turning point, and y-intercept. And this is how Mr. Chong designed a roller coaster track. He has used polynomial to approximate the functions of his roller coaster graph and get his job done. Now, he is ready to pass the graph to the client. And this is the end of our video. I hope you guys enjoy it and learn something new from our video. Thank you so much. See ya!